In this video, let's talk on error analysis. In the previous video, we have learned that no measurement is perfect and every instrument can measure up to a certain accuracy, which we call least count. So, least count is the smallest measurement that can be measured accurately by an instrument. For example, vernier calipers can measure up to the accuracy of 0.1 millimeter or 0.01 centimeter. That means its least count can be 0.1 millimeter or 0.01 centimeter. Micrometer screw gauge can measure up to the accuracy of 0.01 millimeter or 0.001 centimeter. That means its least count can be 0.01 millimeter or 0.01 centimeter. Stopwatch can measure up to the accuracy of 0.1 second. That means its least count can be 0.1 second. Temperature thermometer can measure up to the accuracy of 1 degree Celsius. That means its least count can be 1 degree Celsius. So now let's see permissible error due to least count. The error we can allow due to least count. Permissible error due to least counts. Permissible error due to least count. Permissible error due to least count is the error in measurement due to the limitation or least count of an instrument. Least count of a millimeter scale is 1 millimeter. Therefore, maximum permissible error in the measurement of a length by a millimeter scale may be 1 millimeter. For example, if we measure a length of 26 millimeter, then maximum value of true value may be 26 plus 1 millimeter, which is 27 millimeter, or minimum value of true value may be 26 minus 1 millimeter, which is 25 millimeter. We can combine these two and write it as L is equals to 26 plus or minus 1 millimeter. If from another instrument we measure a length as 24.6 millimeter, then the maximum permissible error or least count from this instrument is 0.1 millimeter. That means we can write it as 24.6 plus or minus 0.1 millimeter. Now, to understand these two better, it means if in an instrument the least count is 0.1 millimeter. So if we measure a length of 24.6 millimeter on that instrument, That means the permissible error we can allow there is 0.1 millimeter. That means the measurement on that instrument can be 24.6 plus or minus 0.1 millimeter. So if you get any of these results, that is 24.6 plus 0.1 millimeter, that is maximum value of true value. So that means you can get 24.7 millimeter is allowed. You can also get 24.6 minus 0.1. You can also get 24.5 millimeter is allowed on this kind of instrument. So that is permissible error. So permissible error is the least count. So due to least count. So in this measurement, if the actual measurement is 24.6, we can still allow 24.7 or 24.5 as our permissible error, since the least count is 0.1. And if the least count of an instrument is 1 millimeter, and on that instrument you measure 5 millimeter, that means we can allow a measurement of 5 plus or minus 1 millimeter on that instrument. That means we can allow 5 plus 1 millimeter. We can also allow 5 minus 1 millimeter. That means the measurement can be 6 millimeter, it can be 4 millimeter if the least count is 1 millimeter. So these are the maximum. This one is maximum permissible error of the true length and minimum permissible error of the true length. So that is permissible error due to least count. Now let's see classification of errors. Classification of errors. Errors can be classified in two ways. Now, the first classification is based on the causes of error. Systematic error and random errors falls in this group. The second classification is based on the magnitude of error. Absolute error, mean error, or mean absolute error, relative or fractional error lies in this group. So now let's take it one by one. So let's start with systematic error. Systematic error. Systematic error are the errors whose causes are known to us. That is, the causes of these errors are known to us. So anytime the causes of errors are known to us, it is systematic error. So this error now can therefore be minimized because we know the causes, so we can minimize the error. Now, the following are few causes of this error. First one, what can cause systematic error? Instrumental error. So if you know the causes of error, then you can know the likely solution to the error. So now, one of the causes of error of systematic error is instrumental error. This is due to faulty calibration or change in condition, e.g., thermal expansion of a measuring scale. So an instrument may also have zero error. A correction has to be applied. So if calibration is wrong, it is sure that error on this kind of instrument will be wrong. But because we know calibration is, if I have a ruler, now if this calibration, yeah, like it should be 5 5. Now if this one is now like this, you will see this is 1 2 3 4 5 6. Then you now have 7. So if this is one, then another one, 1 2 3 4 5. 1 2 3 4 5 2. Now this instrument is wrong because the calibration here should be 1 2 3 4, then it should be 5 next, but we have extra calibration here, so that means this instrument is wrong. Since we know that the problem of this instrument is calibration, we can correct it. So that is instrumental error. Again, another causes of systematic error. The first one is instrumental. So another causes here. Sometimes error sometimes errors arise on account of ignoring certain facts. For example, in measuring time period of simple pendulum, error may creep because no consideration is taken of air resistance. So these errors can be reduced by applying proper corrections to the formula used. Then third one, change in temperature, pressure, humidity, etc. may also sometimes cause error in the results. Relevant correction can be made to minimize their effect. So let's talk about random error. I said under systematic error, under classification of error, if we know the causes of error, then it can be systematic or random. So now the two falls under if we know the causes of error. Now let's talk about random error. Random error. Sorry, classification of error. So we have systematic, and if we know the causes, so it can be systematic or random. So number 2 now, random error. So let me clear this. Now we'll do small calculation or illustration under random error. So random error. So the causes of random errors are not known. So that means if you don't know the causes of random error, we can't correct it easily. So now the causes of random errors are not known. Hence, it is not possible to remove them completely. These errors may arise due to a variety of reasons. For example, the reading of a sensitive beam balance may change by the vibrations caused by the building due to the person moving in the laboratory or vehicle running nearby. So the random error can be minimized by repeating the observation a large number of times and taking the arithmetic mean of all the observations. The mean value will be very close to the most accurate reading. So we need to take the reading, repeat it over and over, and find the arithmetic mean in random error. So let's say A mean. So it will be for A1 plus A2 plus continue up to AN divided by N. So that means if you do the experiment, you repeat the experiment several times, and find the arithmetic mean, you can get a result very close to the true measurement. So that is random error. So when the causes of the errors are not known, so it is random error. If the causes of error are known, then it's systematic error. Now let's say absolute error. Absolute error. The difference between the true value and the measured value of a quantity is called an absolute error. Usually the mean value is taken as the true value. So that means the mean value, we take it as the true value since our result will be very very close. So now the mean value is a1 plus a2 plus an divided by n. Then by definition, absolute errors in the measured values of the quantity are, so that will be true value minus a1. So absolute value will be the true value minus the first trial, because we said absolute value is the difference between the true value and the measured value. So if the measured value is a1, then the true value is am, so which is the mean value. So we take that one as the true value. So that means again a2 can be am minus a2 if you continue this way. So we have an will be equals to am minus an if we continue. So that means the absolute error may be positive or negative. So now mean absolute error. Let's talk about mean absolute error. Mean absolute error. Arithmetic mean of the magnitude of absolute errors in all the measurements is called the mean absolute error. So mean absolute error will be, so we have change in the mean value. So that will be, so absolute error, mean absolute. So that will be delta a1, the first measurement, delta a2. So continue to delta an divided by n. So the final result of measurements can be written as a is equals to am plus or minus the a mean. We take this as our true value. Am, that is a mean, that is an absolute error. We'll take that one as our true the arithmetic mean of all the observation. We'll take that one as the true error. So now this implies that the value of a is likely to lie between, so this result implies that the value of a is likely to lie between am plus or minus, that is am plus the a mean, and am minus the a mean. So let's say relative or fractional error. Note all this formula, it will be useful. Relative of fractional error. The ratio of mean absolute error to the mean value of the quantity measured is called relative or fractional error. So relative error will now be this divided by mean value. Relative error expressed in percentage is called percentage error. So percentage error will be equals to relative error, that is A mean, divided by AM, that is relative error, times 100. So that will be percentage error. So we can see simple example on this to illustrate all these errors. So now before we see example, so let us recall everything. So the first one we talk about, the formula is random error. So the random error can be minimized by repeating the observation a large number of times and taking the arithmetic mean of all the observation. The mean value will be very close to the most accurate reading. That means the mean value of random error is, so we summarize everything, that will be, let me write it. So mean value AM is equals to A1 plus A2 plus AN divided by N. Then we say absolute error, the difference between the true value. So absolute error is the difference between the true value AM and the measured value. So the measured value can be anything. So if the measured value is A, so it will be A. So that is absolute error, the true value minus this measured value. And you know, in this case the measured value will be many. So that's why this can be the true value minus measured value, the first measured value, the true value minus the second measured value. So it depends on the number of measured value. So the true value minus the measured value. So this will be absolute error. So now this can be positive or negative. We also have mean absolute error. Mean absolute error. So the mean absolute error is the arithmetic mean of the magnitude of absolute error in all the measurements. So arithmetic mean of the magnitude of absolute error. So this is our absolute error here. So that means I can change this one. So it depends on my A1, because this first one now, this will be the A1, this will be the A2, delta A2, and this will be delta AN. So delta A1 will be AM, the true value, minus the measured value. So that means mean absolute error will now be arithmetic of the magnitude of the absolute error. So that will be the A1 plus the A2, that is delta A2, plus delta an divided by n. So the final results of measurements can be written as, in this case, can be written as am plus or minus the a mean. So the a mean is all the values, and we can split this to be plus or minus. Then relative or fractional error. Fractional error or relative error. So the fractional error is the ratio of mean absolute error to the mean value of the quantity measured. So the mean absolute error, so this one is the mean absolute error, which is this result. So mean absolute error is the am divided by the mean value, in which we represent as am. That's fractional error. And percentage error will be the fractional error, that's divided by am then times 100. So this will be percentage error. So now we will see example in next video based on all this error and their classification. Thank you.